the Sustainability Management Master's Program, you are answering one simple question. Do you care about your future generation? If you care about your kids, their grandkids, then you care about sustainability. And a sustainability manager is someone who has the tools to make people understand how they can contribute towards developing a sustainable world. We have both part-time and full-time students. Our curriculum is 30 hours. Instead of thesis, we have a research project course and a seminar course which provides them with the kind of research background they will need to be successful in their job. But at the same time, sustainability is not always everything about environment. It also relates to the business. They will take a sustainable business strategies course. They will take a project management course. Most of these courses are going to be taught by industry people, the people who are doing sustainability on a daily basis as a part of their job. Any organization that has a large number of employees and has a physical infrastructure, they will have to have a sustainability office. If you have the passion to develop and maintain a sustainable world, come to us and we will help you shape your passion into a career which will create an impact. By Brown and Caldwell, who are a co-sponsor of the Hugo News Sustainability Seminar Series. So they are, I had to look up your new designation, George. They are pharmaceuticals client service manager and a very good friend of the program. George Hollerbach is here with us. So he is going to introduce his colleague, Jeff Caputi, who will be our speaker today, and he will talk about their Gowanus Canal CSO abatement project. George?
Okay, hey, thanks, Dibs. So I've known Dibs, and I've been involved in the Stevens Sustainability Program for at least, probably over 7 years. And I recently joined Brown and Caldwell in May of 2024 this year, and very pleased to continue my relationship with the Stevens Sustainability webinar series and the Center for Sustainability. Big believer in what Dibs is doing and what he's led. And I did want to give kudos to you, Dibs, for your recent selection as a 2024 ROI influencer in the environmental sector. So congratulations.
Thank you.
Yeah, for those who don't know, it's part of a select group of people, of New Jersey residents, who really influence the promotion of clean and sustainable environment. So I wanted to introduce my colleague, Jeff Caputi, out of our Ramsey, New Jersey office. I've known Jeff for probably at least 20 years, and he's one of the main reasons why I left my former company to go to Brown and Caldwell, and I'm really happy to be here and finish up my career at BC. To me, they've always represented being the most well-known company in industrial and municipal wastewater treatment. So that's sort of my bread and butter my whole career, and I'm really happy to be here. So Jeff is going to speak about a very interesting project that he's been working on for a number of years regarding the Gowanus Canal. And it's a combined sewer overflow project, and very interesting technology, and a major capital project. And also it was sited in a area that basically had to go through a number of remediation steps in order to build a new building. So it's a really interesting project. And there's a lot to it, a lot of stakeholders. And so with that, I'll pass it on to Jeff.
Well, thank you, George, and thanks everyone in attendance. Nice to meet you all virtually. I'm going to talk for, I guess, about 40 minutes or so about this project, and I could talk for hours about it. There's so many aspects to it. I've tried to focus it to give a brief introduction on the site and the site history and kind of the regulatory status of it, and then quickly give folks a sense of the design of these facilities, the design process, and the site remediation aspects. That's really my area in environmental engineering and consulting is in site remediation, and there's a significant aspect of that to this project, which is a Superfund site. And then I will talk about the sustainability aspects of the project, focusing mostly on the sustainability that we built into the construction phase of the project, the considerations there. So I'm going to go relatively quickly to try to get through everything. I also have some photos at the end of the actual construction that's going on now. That's pretty cool. So hopefully we'll have time to show a few of those at the end. So here we go. So quickly, agenda, kind of just went through this: safety minute, introductory, regulatory design, the remediation scope, and then sustainability considerations. We always start out meetings with the safety minute. So just real quick, it's starting to cool off a little bit, and before we know it, it could be quite cold. I know not too far from here, some places are getting snow already. So just real quick, cold stress is something to be aware of when folks are out in the field and being exposed to cold temperatures for extended periods of time. There's a number of factors that can cause cold stress: exposure to cold water, dampness, high and cold winds, and cold temperatures. And symptoms include hypothermia, frostbite, trench foot, and chilblains, which is repeated exposure of the skin to temperatures that are just above freezing. And then some of the measures that you can take to be safe and be aware of this is always wear the proper clothing for cold, wet, and windy conditions. Take frequent breaks in warm, dry shelters. Try to schedule work for the warmest part of the day. Avoid working when you're exhausted or fatigued. Keep extra clothing handy in case you get wet. Drink warm, sweet beverages and avoid drinks with caffeine or alcohol. Eat warm, high-calorie foods, and understand the symptoms of cold stress, such as reddening skin, tingling, swelling, leg cramps, numbness, and blisters. Okay. So the Gowanus Canal is in the heart of Brooklyn. It's 1.8 miles long. On average, it's about 100 feet wide. It opens up into Gowanus Bay on one end. It dead ends at the other end, which has always been an issue for the canal. So it is subject to tidal exchange, but it doesn't flow. It's not a complete flow through system. So there is more potential for stagnation of water. There's 7 bridges or viaducts that cross the canal, and it's generally been recognized as one of the most polluted bodies of water in the US, with a host of most of the types of contaminants that you may have heard about, including volatile and semi-volatile organics, PCBs, pesticides, metals. There's an interesting history. The canal was created in the middle of the 19th century. Just a quick anecdote, a lot of people don't realize that Brooklyn wasn't always part of New York City. So back prior to the early 1900s, on its own, Brooklyn was the 3rd largest city in the US before Brooklyn and Queens became boroughs as part of New York City. During the peak of the industrial activity along the canal, around the middle of the 1900s, there were as many as 100 cargo ships passing per day. There were all sorts of industries along the canal, from flour mills, cement works, tanneries, oil terminals, chemical and fertilizer plants, and so on and so on. There were also 3 former manufactured gas plants situated along the canal. And for folks who may not be familiar with that, prior to the advent of pipelines to convey natural gas across the country, it was common to burn coal in local plants to produce gas called manufactured gas, and those facilities left quite a legacy of pollution from those activities. Just a little bit more on the site history. So over 50 industries were located along the canal in 1942. There were 14 combined sewer overflows, or CSOs. So, CSOs are associated with older sewer systems that you see in older cities where the sanitary flow and the stormwater are not separated. So during rain events, you get a tremendous increase in flow through the system. It's too much volume for the wastewater treatment plants to be able to treat. So the flow goes over a weir and discharges untreated into a water body like the Gowanus Canal. And you can see here what it looks like when there's a CSO discharge at the head end of the canal. It's colloquially referred to as a punami. And over the years, from both the CSO discharges and the discharges from all the industry along the canal, the sediments in the bottom of the canal became quite contaminated, and it is this sort of gooey black colloidal mixture that is often referred to as black mayonnaise. Over the years, there were a number of measures implemented to improve the water quality. Sewers were put in to take sewage that used to go untreated directly out to the harbor. There was a flushing tunnel at the head end of the canal that was put in to bring clean water into the canal and help mix that in. There were upgraded sewage treatment plants constructed, and there were stormwater management measures implemented. Okay, I'm going to move on just to a couple slides here to give you a sense of the regulatory status of the canal. So in 2009, EPA proposed listing the canal on the national priorities list under Superfund. And for the next few years, there were investigations and feasibility studies conducted by EPA's contractors, which led to EPA issuing a record of decision in 2013 that lays out what the remedial measures are to address the historic contamination in the canal. The canal was divided into sort of three sections called remedial target areas 1, 2, and 3, starting at the head end and working out to the bay. The major elements of the remedy included dredging the contaminated sediments from bank to bank, stabilizing, solidifying non-aqueous phase liquids, which are primarily coal tar residues from the former manufactured gas plant sites, as well as possibly some other non-aqueous phase liquids resulting from historic discharges from industrial dischargers. That would be in the native material below the soft sediments after they're dredged out. Installing a multi-layer cap over the canal bottom after removing the sediments, and then control of the CSO discharges. There's a number of responsible parties that have to work with EPA to implement and to fund the remedy. The way things got divided up, the City of New York Department of Environmental Protection is the sole PRP for addressing the combined sewer overflow, whereas the sediments remediation has a group of industrial companies that are responsible parties for that as well. EPA issued some administrative orders to implement the record of decision, and as I mentioned, the city is the lone responsible party for addressing the CSO discharges. The remedy for the CSO discharges includes designing and constructing 2 large retention tanks The concept being that when wet weather occurs and the flow through the combined sewers is too great for the treatment plant to handle, rather than the excess flow being discharged untreated into the canal, it'll be rerouted into these large holding tanks. And then once the rain subsides and the treatment plant has the capacity to take the additional flow and treat it, it can be bled back off from the storage tanks and sent to the treatment plant. The remedy called for 2 tanks, an 8 million gallon tank near the head end of the canal and a 4 million gallon tank around the midpoint of the canal. And there's kind of a cutout of a map here, and you can see the canal. This is the head end up here where my pointer is. And there's a pump station there that goes to the existing Gowanus wastewater treatment plant. And there were 2 sites considered for the CSO storage tank, which are referred to as the RH3 and the RH4 site. And then down about halfway down the canal is where the second tank was located. From here on out, I'm going to focus on the head end facility, which is further along in the design and actually partway through construction now. So the DEP entered into a consent order with EPA in 2016 that laid out specific milestones for design and construction of the remedy at the head end, which is referred to as RH034 facility. That's just the designation of that CSO outfall. And as I mentioned, stipulated milestones for design submittals, for the city to acquire land as necessary to build the facility and to implement the required remedy. So it turns out that the preferred site for this facility is on the location of one of the former manufactured gas plant sites. And National Grid, the current utility, has responsibility for cleanup of the former MGP sites. So they are working with the state agency, the Department of Environmental Conservation, to perform remediation for the former MGP site. And some of the activities between the CSO facility and National Grid's remediation overlap, so adding sort of complexity to the project. The parties had to cooperate and work together on various elements of the project. Going to quickly walk us through the design process. The New York City DEP has a very SOP driven, a very detailed design process, as you could imagine, for these facilities that are going to be put into use to protect the public and are going to last for 100 years or more. The process goes through a facility planning stage, which includes a series of workshops to bring all the various stakeholders together and to develop the goals for the project and the approach. That leads then to developing the basis for design. And when that's complete and signed off on by all the stakeholders, you then can start on the detailed design. Because of the complexity of the project, it was divided into 3 separate design and construction packages. So the first was demolition and preparation of the site, because there were existing buildings and facilities that need to be removed. The second phase is the subsurface work for construction of the 8 million gallon tank. And then the third stage is the building that goes on top of the tank that houses some of the treatment equipment, to includes large screens to screen out debris that's included in that's entering the tank, and other facilities to remove grit and manage the solids and that sort of thing, as well as odor control systems. So the goals of the project were developed early on, and that included designing the facilities to be compliant with regulatory requirements, making them safe and efficient to operate, make sure that the facilities are consistent with the character of the neighborhood and meet the desires of the community stakeholders, and then to design them to be sustainable and to meet today's requirements for sustainability, which I'll be talking about more as we get further into it here. This is just a process flow diagram for the facility. I'm not going to spend too much time here, but needed to accommodate the flow from the design storm, which was a peak flow in a typical year. You can see flow enters and goes through screens and degridding units, and eventually ends up in a series of compartmentalized parts of the tank. So the reason it's designed in sections rather than just being one large tank is that the majority of the flows during a given year might only be enough to fill the first or the second chamber, and therefore it reduces the maintenance requirements rather than letting the entire tank fill up every time that there is an overflow into the tank. This is an artist's rendering of what the facility will look like once it's constructed. You can see the head end of the canal over here. That will be the head house building. It contains the treatment and odor control equipment. And then the rest of the site will be turned into a park. There's a park adjacent to the site across the street. So this will be sort of an extension of the park, and will create additional open space for the community. And this is another artist's rendering. You can see with the brick structure tying into the existing pump station and trying to be consistent with the character of the neighborhood. All right, so going to quickly go through the remediation scope here. So the tank, in order to construct the tank, it is necessary to first build a support of excavation before the mass excavation can be performed, and the tank, the concrete can be poured to construct the tank. So we call a supportive excavation a SOE. In this case, it's a slurry wall construction that goes all the way down 200 feet and ties into the underlying bedrock. And then it also forms the outer walls of the tank when it's constructed after the slurry wall is completed. We're working on a contaminated site, so we're surrounded by impacted soil and contaminated groundwater that has to be managed. So it's not your everyday construction project, to say the least. So we first conducted a pre-design investigation that was fairly extensive investigation to characterize the contamination in the soil, groundwater, soil vapor. The main constituents are material associated with the former manufactured gas plant site. So if you've never seen coal tar, it's similar in some respects to the creosote that you see used to treat telephone poles. Very thick, viscous liquid that was generated in large quantities by these former MGP sites, and much of it ended up in the subsurface and in water bodies, back in the days before we had the sort of environmental regulations and best practices that exist today. One of the things that we spent quite a bit of time looking at from a sustainability standpoint is the potential for beneficially reusing some of the soil that needed to be excavated and managed. So this just shows quickly what some of the regulatory limits are for the contaminants that we were dealing with. The light blue being the most stringent criteria that would have to be met for the soil to meet residential use criteria. The green would allow for commercial use, and the darker blue here is for protection of groundwater. and I'll just keep moving through here so we have enough time. This just shows the layout of the investigation. So the investigation included both sites, the RH3 site and the RH4 site, because at that time it had not yet been determined for certain which site the facility would be built on. The RH3 site immediately adjacent to the canal was the New York City DEP's preferred location. The EPA preferred the RH4 site, which is the existing park, because DEP already owned the property and wouldn't have to acquire it. However, DEP was very reluctant to take over the park in order to build this facility, because it was the only park anywhere nearby in that part of Brooklyn. And in order to acquire that property for the facility, they would have had to find a new location and build a whole new park with a new public swimming pool and all the facilities and such. And ultimately, DEP was able to acquire the preferred parcel, and we were able to focus the rest of the work on that location. This is just a cross section that shows the contamination in the subsurface. The darker reds and browns are where we encountered separate phase product, coal tar from the former MGP operations. And then the contractor, when mobilizing to the site, had to do their own additional investigations. So they drilled borings all around the perimeter of the tank where the supportive excavation would be constructed. And you can see the red locations are where coal tar was encountered. So mostly concentrated on the southern end of the site, not so much on the northern end of the site. And then they also gridded the interior where the soil would be excavated to construct the tank. And similarly, southern end of the site, most of the locations showed the presence of coal tar, whereas the northern part of the site did not. We did some 4D modeling and looked at the feasibility of implementing the construction and how it would need to be done. This is just a still shot from that. You can see in part of the design of the supportive excavation includes these this bracing, these cross-lot struts. So it's another complexity is having to work within this these constraints to work down in the area and to do the excavation and to get the soil up out of the excavation. And this just shows kind of the flow around the site, so the excavation work would be occurring in here. Trucks would enter along the side of the canal. There's a soil staging area over here. So all those logistics had to be worked out. It's a very congested part of Brooklyn. The streets are narrow and filled with parked cars, and very difficult for construction equipment and dump trucks to get in and out of the site. This just shows the staging area. So this is sort of the earlier phase of the work where the supportive excavation is being constructed. So you have a slurry plant to produce the material for the slurry wall, in addition to your temporary electric, construction trailers, and then a construction water treatment system to treat any contaminated water that needs to be generated or managed during the work. And then once the supportive excavation is complete and we start excavating the soil in the tank area, there's the staging area gets converted for soil processing, but you still need most of the other facilities. That's just a picture of what the spent slurry looks like coming off of the slurry desanding unit. The slurry gets recycled. It's used to keep the trench open while you're digging and constructing the supportive excavation, and eventually the spent slurry needs to get disposed of. So part of what we had to plan for was managing these various waste streams. Most of the material requires special handling to dry it before it can be transported off site. And then we looked at a lot of different options for And I'll talk more about that when I get into the sustainability section shortly, but we looked at a lot of options for potential reuse of the material, avoiding putting it in landfills if at all possible. So that's kind of everything leading up to here, where I want to talk now about some of the sustainability considerations. So there's actually quite a bit of supporting local laws and plans and guidance in New York City for sustainability. There's requirements under New York's from the mayor's office, Plan New York City 2030 and One New York City. There's a number of local laws that deal with emissions from construction equipment, water conservation, recycling of materials, utilization of electric vehicles, renewable and more sustainable forms of energy and the like. And then BEDC, which is part of New York City DEP, it's the Bureau of Engineering, Design, and Construction, has their own standard operating procedures. So every project needs to have a sustainability management plan prepared. That plan gets workshopped with all the various stakeholders. There's rating systems. There's certain requirements for energy conservation, climate adaptation, use of recycled materials, reducing waste, stormwater mitigation. So some of you may be familiar with the Envision program, which is very popular these days. There's also LEED, which is similar. Envision seems to have gained a lot of popularity recently. So that's a tool for evaluating and rating the social, economic, and environmental benefits of all types of civil infrastructure projects. So it provides a framework, and you can get designated at certain levels of recognition based on how many credits you're able to attain for your project. And the DP follows that, implements that program, and the design of the facility looked to acquire as many Envision credits as possible. I believe going for gold certification. There was also, and this pertains to the fact that the facility is being constructed on a Superfund site. So EPA has what they call their clean and green policy, and that policy, which applies to any remediation projects, establishes preferences for using renewable and conservative and efficient energy and Energy Star equipment, using cleaner fuels and clean diesel technologies, water conservation approaches, sustainable site design, reuse and recycling of material where feasible, environmentally preferable purchasing, and looking at minimizing greenhouse gas generation. Some of the construction-related considerations were looking at energy and water use during construction, minimizing impacts to the neighborhood in terms of noise, odors, traffic, impacts during transportation, impacts during treatment of any of the material, and then final use of the material where it's possible to reuse or recycle material. There were a number of evaluations that the team conducted. Some of what we found was there were limited differences between the options for energy conservation. There were some more significant differences looking at transportation and treatment options. We did a life cycle analysis of soil transportation and treatment options and looked at the sort of pros and cons of potentially transporting material farther away in order to treat it further so that it could be reused, and which options had a greater carbon footprint than others. This is just another slide that shows, some of the regulations and agencies that have a role in reducing energy usage. So there's New York City has energy conservation codes, for example. There's federal agency energy policies. The DEP has its own standard operating procedures, and then the New York City has local laws, which I mentioned previously. So we looked at we're including requirements in the project specifications for use of Energy Star equipment, preference given to efficient generators, restrictions on idling of trucks and equipment, lighting preferences, efficiencies of lighting and air conditioning equipment, shutting off lights when not needed, where trailers are placed, and even consideration to generating electricity on site if determined to be feasible. We also looked at combustion byproducts, potential to replace traditional Portland cement with amendments that reuse things like fly ash and other products. Benefits from saving energy, reducing greenhouse gases, limiting the need for concrete at the site. And again, I mentioned here fly ash, kiln dusts, other materials that can be used for stabilizing, solidifying soils as necessary to reduce free liquids before they get put in trucks and sent off site. And then there were indirect energy reduction measures, like one of the DEP's SOPs requires a construction waste estimate report, and then tracking of the waste generation and how it's managed during construction, looking at recycling locally construction wastes as feasible, other best management practices, minimizing greenhouse gases, looking at reducing the purchase of products or increasing the purchase of products that have recycled content. So the greater use of products with recycled content, such as some of the products that are listed here. The specs require the contractor to keep records of all of these items, including electricity usage, makeup of any renewable energy sources, use of coal combustion products, information on fleets and vehicles, various other requirements here. Monitoring and managing energy was built, how that's built into the equipment and the computer control systems. Soil management considerations, again, we look to promote reuse if at all feasible. Need to consider how does that impact the project schedule, community impacts, cost, complying with the applicable regulatory requirements. The New York State DEC has regulations that need to be met in order to reuse materials from a contaminated site, and it's a pretty detailed process that you have to go through, and there's certain types of reuse that are allowed based on the amount of contamination that may be present in the material. We determined we had would have about 140,000 cubic yards of soil excavated. The possible reuse scenarios included reuse as general fill. That might be possible for some of the lesser impacted materials, like on the northern part of the site and in the shallow soils that were not as contaminated. There is a possibility of sending soil off to thermal treatment facilities that will heat up the soil and drive off volatile contaminants and allow the treated soil to then be beneficially reused. There's also restricted and limited use fill that sometimes can be used as subgrade in construction projects. For example, if it's going to be paved over or a cap is going to be placed over it so that public and ecological receptors wouldn't be exposed to the underlying material. And then kind of least preferred is sometimes moderately impacted material can be used as daily cover at a landfill. So rather than being buried in the landfill, it can be beneficially reused as material that they need to cover the waste that's disposed on a daily basis. So as I mentioned, DC has regulations that spell out all the requirements that need to be met for beneficial use. New York City also operates a soil bank that accepts soil that meets residential use criteria. Unfortunately, we weren't going to have much or any of that for this site, so we weren't able to take advantage of the soil bank. Try to get through the rest of it here. I think I'm close to the end. Factors influencing treatment and reuse options, contaminant levels and types, the physical property of the soil. Obviously, it has to meet the physical needs of how it's going to be reused. The ease of segregating soils as you're going through the excavation process. You can only do so much sort of surgical removal of soils to separate, maybe soils that are clean enough to be reused from the more contaminated. At some point, it becomes impractical. And then the availability of the facilities and potential reuse sites at the time that the project is being constructed. And we also looked at various transport locations and pros and cons and the relative sustainability of trucking versus barging versus use of rail. I won't go through this in detail, but you just could kind of get an appreciation for sort of the complexities in evaluating these reuse options for the soil. First determining, is it a hazardous waste under RCRA or not, and then looking at further details as you work your way through the chart, and then also looking at the pros and cons of the various transport options. We did this life cycle analysis, and we found that there's quite a bit of energy used and greenhouse gas emissions associated with sending soil off for thermal treatment in order for it to potentially be reused. So from a sustainability standpoint, it really didn't pencil to send the soil off over a long distance, use a lot of fuel, generate a lot of emissions, then send it through a thermal treatment process and then bring it back to some location to be reused. So we kind of ruled that out. And we looked at other treatment options based on the relative contamination levels of the soil through that process. That's just another sort of refined analysis that was done. So, looking at the different transport and treatment and disposal and reuse options to see which was the most practical for the project. And that's really the end of the presentation, other than some photographs I have if there's time to show them. But let me pause here because I think just about right on time for.
Yeah, you can show the photos and then we can start the Q&A.
Okay.
It's a very interesting project.
Okay, thank you. Yeah, so the second phase, the CP2 part, which is the subsurface work to construct the supportive excavation and then the excavate down into the subsurface soils and form the underground tank is happening right now. And this is an aerial photograph taken from a drone, and you can see how congested the site is. And this is early on, and even this doesn't even show all the cranes and things that you'll see in some of the subsequent pictures. The canal is up here in the upper right corner, and you can see the elements of the trailers and temporary electric and construction water treatment system, many of the activities going on here. This is a view taken from the roof of an adjacent building. You can see all the cranes and equipment on the site, and looks even more congested in this photo. Here you can see the dredging going on in the canals. So that was one of the considerations when we looked at potentially barging material off of the site, because, you know, at face value, you might say, oh, you're right next to a canal, you know, instead of trucking, why don't you barge it? But there was going to be all this remediation work going on in the canal at the same time. And then you have issues with all of the bridges and having to open and close drawbridges and the effect on traffic and everything. So there were a lot of hurdles to overcome in order for us to make barging work. So at the end of the day, we did end up trucking for the most part. These are noise sound barriers being erected. This is the guide wall. So this is for the supportive excavation to be constructed. The first step is to construct this guide wall, and then the SOE will be built in panels. So you can see they're kind of measured off. And then you can see in the next phase, this is the clamshell that was used to excavate about the first 70 feet to construct each panel as part of the perimeter supportive excavation. And then on the right here, this piece of equipment is called a hydromill, and you can see it has these two cutter heads on it. And this is capable of being extended to great depths and even to excavate into the upper surface of the bedrock, so that the slurry wall could be keyed into the bedrock. This is the slurry plant here, and on the right, this is the desanding unit. So as the slurry, it's a mixture of bentonite, creates a more viscous material that is pumped into the excavation, and it actually serves to keep the excavation open so it doesn't collapse during the soil removal part. And then as the slurry gets too much sediment in it, it goes through this desanding unit, which removes the solids, and then it's recycled back and used again. Here you can see this tent or sprung structure that was constructed over the desanding unit, because we found that there were a lot of odors coming off of it from the coal tar. So a tent was placed over it, and then blowers were put in to create negative pressure and remove the air, and then that was run through carbon filters to remove the contaminants from the air, reduce the odors. This is the rebar cages that get lowered into each panel for structural support for the supportive excavation. Pretty massive structures to put together. Here's a concrete pour. So after the rebar cages were dropped into to the panels, the concrete is poured to complete the panel. And then this last photo over here just shows some of the soil being excavated, and you can see it has that white appearance to it. That's not snow, that's from foam that is sprayed on top of the soil to reduce the odors coming off of it from the contaminants that are present. So I think that's that's about the end of what I had to present. I hope I didn't go too fast, and I hope it was of interest, and be very happy to discuss further and answer any questions that I can.
Yeah, that was an excellent presentation. You packed a lot of information there, Jeff, and but very interesting project. So just for everyone, like Khalid